that group. This next group is the flavonol group, flavonoid group, bioflavonoid group, however you want to say it. This is an extremely large group. And every year there's international conferences that last anywhere from 1 to 5 days just on the latest search on flavonols. So we're going to miss a few pieces in the information here. I've tried to cut this part down as small as possible because there is so much information. And I was looking at it earlier today. I wanted to make it a lot smaller so we could get through the material. We're classifying flavonols as a glycoside because it can have a sugar on it. Lots of scholars around the world, especially in Europe, they consider them polyphenol systems, and they don't really work as a glycoside. It's immaterial which group you call it, but they are a group unto themselves. They're lots of times the colors in the plants. They can be anywhere from yellow to oranges to reds to blues to deep purples. These are the colors you're going to find in blueberries and cherries and those kinds of things. They're a very bioactive part. There's a huge group of flavonoids that we can't see. They absorb ultraviolet radiation. In fact, there's a huge group and we can't see, but insects can. So you might look at something like a petunia, like a white petunia, and it has blue in the ultraviolet light, landing lights for the bees to go in. And it's literally, if you see them on an ultraviolet filter, it is so cool because it's a landing pad for the bees so they can stick their little bum in there and play around with the pollen in there and take some way to make some honey. So most flowers are highly bioflavonoid in the ultraviolet ray area. By the way, flavonols are toxic to insects, so they kind of maneuver through what they're considered a radiation zone they don't want to touch because it's poisonous to them, and they come in and it helps them figure out to land. We won't see it, which I think is very cool to make it both toxic and a color they can only see as a landing pad. So who says there's not a plan behind nature? We just have to learn about it. They've got their dream together. We just have to see if we can catch on to their dream. This toxicity will obviously protect the plants from predators. So a lot of organisms will not eat a plant until it's fertile. Until it's been pollinated. An awful lot of plants will put out these colors that we can't see that'll warn other organisms not to eat them. Soon as they're pollinated, the colors will change in the petals so they can be eaten and fall off, and they can be useful, taken away, made into all kinds of various things by the insects. But then around the seed coat, that becomes flavanol rich, and so it won't have this. A lot of fruit have it until it gets completely mature, and when it gets mature, it stops having the heavy flavanol thing, and the organisms will get there until it rots or whatever. You're going to find a lot of flavanols around fruit areas where the seeds are. For example, the inside of the rind of an orange or a grapefruit, that white stuff that we call white, is totally toxic to insects, so they're not going to eat the orange until the orange can rot enough for the seeds to be ripe to be able to grow. So they can use that as their own food. Peppers, the rutin is that white stringy stuff in the peppers. So an awful lot of people want to cut that out, especially in Europe. You see them, they cut it out very delicately, make sure they don't have any of that white stuff from the orange or any of that white stuff. That's the healthiest part of the whole blooming orange of the pepper. And I've tried to tell them, but they're just not going to believe you. They know better. That's all there is to it. But the point here is that not only these things work in the UV spectrum, they're also plant sunscreen. So they protect the sun. As you know, these plants are hanging out in the sun all day long. Can you believe it? They live outside. And because of it, they don't want to get skin cancer. They don't want to get cancer themselves. So the two groups of chemicals they use the most are the flavanols to protect themselves from the sun's radiation, and the carotenoids, which we'll talk much later in the class. Those two classifications of chemicals protect the plants from the radiation that they would get, so they're all right. So we can take those things into our body. They also work as growth regulators in the plants, and they also work on if the plant is injured. Large amount will be produced around that area, again to make sure insects and organisms don't climb in through that portal to get deep into the side themselves. So they're protection agents for the plants, and they can certainly be protections for us. This is probably one of the biggest reasons I can think of eating a rainbow diet. The concept of eating a rainbow diet, eating foods with many different colors. Don't just have green peppers, have red peppers, orange peppers, yellow peppers. Don't just have yellow corn, have purple corn, have red corn, have all kinds of different colors of corn. The more variety of color you eat in your diet, the more flavonols and the more carotenoids you get, and literally the healthier it's going to be for you. They are both bitter and sweet, and which is kind of interesting. It shows how our bitter and sweet receptors on our tongue are very close to each other. Again, there's over 4,000 kinds of different polyphenol flavonols that we can work with. There's a few we're not going to talk about tonight. They're the reds, the blues, the purples. They're in vegetables. They're in fruits. They're work on many things. They're definitely antioxidant, anti-inflammatory, cardioprotective, and they work on them. This is some of the groups that you have on page 28 of your manual, some of the variations in them. So you can see they're all based around this skeleton. It can be stretched out, but it usually creates a ring. So all of them have this structure to a degree in them. It's a 6-carbon rings, these rings, and there's groups of these rings. As soon as it has an oxygen on it or an OH on it, it's a phenol. And so that's why some people call them polyphenol chains. And so some of them have OHs, some of them don't have OHs, but most of them do have the OHs in them. And that phenol itself is what becomes toxic to the insects and becomes problematic to them. There's many, many different ways you can break up these things. Flavin means basically the nucleus of it. Literally a flavanol means it has an alcohol in it. We talked about that when we did the basic chemistry, how that's a major functional group, and it becomes a major functional group in here. Here we'd have an OL or an OH group or an AL group, an alcohol group, and that's what would make this a flavanol or an alcohol.